Hey guys, my name's Eric.
My name's Sam.
Welcome to 3D Aero Ventures. So today we're bringing you a really cool video. This is my son Sam. I want to introduce him to RC modeling. So I want to do it in kind of a fun, cheap, and quick way. So we went and bought one of these cool 4-foot foam gliders. And honestly, these are really fun just as it is, just tossing them back and forth, right buddy? Mm-hmm. But that's not really good enough for us. I actually have a lot of experience in CAD and 3D printing. So we're gonna design a little power pod in SolidWorks and then 3D print the pod out of PLA, and we're gonna turn this thing into a fully functional RC model. Stick with us. Hopefully you enjoy. Let's get started.
Let's do it!
Hey guys, quick break from the video just to say thank you to our sponsor SolidWorks for sponsoring this video. We've got a series of 3 more videos coming for you that we're gonna get a little bit more complex with each one, showing you how to use CAD and 3D printing to build awesome RC airplanes like this one. Check out the link in the description below to learn more about SolidWorks products and their awesome community around the globe. There really is no better CAD community than SolidWorks in my opinion. So thanks again SolidWorks. Back to the video. All right, Sam, I have one little lesson I want to teach you before we start modeling this thing up. Yep. So let's pull it out of the bag and put it together.
Here, I'll hand you the pieces.
Okay, fuselage. This is called the horizontal stabilizer. I'm gonna put the wings on and you can put the tail on.
This is gonna be a good YouTube. You should call it Eric's and Sam's YouTube.
So, I want to teach you about balance. So with an airplane, you want to keep it nice and balanced, nice and level, just like a person, right? So like you, if you're too tail heavy, that means you're too butt heavy, you're gonna fall on your butt and hurt your butt. If you're too nose heavy, you're gonna fall forward and fall on your nose and hit your face on the ground. So with an airplane, you want it to be nice and level. You don't want it to be too nose heavy or too tail heavy, or it's not gonna fly really well. We know, right, out of the package, this thing flies pretty well, nice and level, and it glides really nicely. So we're gonna see where it balances by holding it under the wing, and then we wanna make sure anything we add to it balances at that same point. So here, I've found these 2 little spots on the wing. They feel like little circles.
Yep.
And it just happens that right on those little circles, it balances really nicely. And honestly, you want to err on the side of a little tiny bit nose heavy, and it'll be really stable when it's flying.
Yeah.
So I know those spots are pretty level. So let's grab a ruler. I've got a ruler right here, and I've got a marker. So I want to mark on the fuselage where that balance point is, so we know anything we're adding to the fuselage is going to be in the right spot. So I'm just going to measure between those 2 points I was touching with my fingers, and I'm just going to mark on the fuselage. Right there, that's our balance point, okay? So anything we add to the fuselage needs to kind of hover around that balance point, and we'll check the balance again. The cool thing is the battery is probably one of the heaviest parts. So we can leave the battery to the very end, and then we'll just position the battery anywhere on the fuselage where it balances it out nice, and it'll fly super great. So guys, stick with us. We're gonna start designing and building. We'll be back to assemble everything together after we've designed the power pod in SolidWorks. 3D printed it on our machine here at home, so stick with us. Now inside SolidWorks, I'm ready to design the power pod. A technique I find myself using a lot lately is designing around an imported image, which comes in handy in this case as we want to make sure our part fits the fuselage nicely. This part may look pretty simple in the end, but I did end up having to use some of the more advanced features like loft and boundary, as well as several surfacing tools to get the final organic shape I was after.
part is hollowed out to a wall thickness equal to the nozzle diameter of my printer, in my case 0.4 millimeters, so I can be sure it is as light as possible. But I also added some ribbing to give this pod some added strength. I also added an internal channel for routing the motor wires to keep everything looking nice and clean. Once I was happy with the overall design from both a technical and aesthetic perspective, I was ready to print. With the parts designed and 3D printed, we were ready to assemble the glider, starting with supergluing the motor pod parts. We needed a longer lead on the motor, so that called for some light soldering. And one technique I like using for creating pockets or recesses in the foam is to just trace the area you'd like to cut away, and then cut that outline with a very sharp X-Acto knife. And simply use needle nose pliers to pull out the foam in the area you don't need. This leaves a nice clean edge around the recess where you made your X-Acto knife cut. And the rough bottom face will get covered up, but if you need to smooth it out, you can just use a little bit of sandpaper. I'm using a very simple control board with built-in linear servos that I pulled off of an old park flyer I had lying around. To me, this seemed a really good option to keep our glider super light. Check out the video description below for more info on the motor size we used, the control board, and battery we used. Now we're ready to create the recess for the cabling using the same plier technique, and we can cut the motor lead to the proper length. Before gluing the control board in place, I needed to cut the elevators from the horizontal stabilizer. And I cut a 45-degree bevel on the bottom side of each elevator so that they would hinge properly. If you leave that face too thick, they would have nothing to rotate around. With these foam gliders, you can use simple packing tape for your hinges. Then we were ready to glue on the horizontal stabilizer. Solder the motor leads to the control unit, and hot glue the control board into place. But always remember to test your electronics before getting too far. Luckily, I tested the motor before permanently gluing the pod into place, and I caught a major mistake.
Where do I press?
This one, forward. Forward. Move it up just a little bit. Uh-oh. Go ahead. Oh no!
What?
It's going the wrong way.
I had a few leads reversed on the control board side, but I was able to make a quick correction and we got the motor spinning the proper direction. I chose to permanently glue the power pod in place using a 2-part epoxy, but you could easily mount it with screws using the provided screw holes in the design. You would maybe just need to add some support to the bottom side of the glider using some spare plywood. Finally, we were ready to hook up the linkages to the elevators. I've chosen to mix the elevators with aileron control, also known as elevons. They will act as an elevator and ailerons to give me pitch and roll control. And we use a strip of Velcro to cover up the motor wiring, so this gave a nice clean look. And also it's a long strip, so it gives us plenty of options for playing with the battery position to get the balance just right. And for the most important part of the build, the stickers. With our glider built and electronics tested, I was ready to venture outside the following morning for the maiden flight. One of the things I love most about this hobby is it allows you to get outside to beautiful places to enjoy it. And because this particular glider is so light and durable, you can adventure virtually anywhere to fly it. But you don't have to travel to far off exotic places to enjoy the benefits of connecting with the outdoors, to get a little peace and solitude in your life out in nature. Sometimes, amazing places like this are where we fail to look most often. Right in our very own backyard. I hope after watching this video you walk away excited to take on a new project like this. But most of all, I hope we've inspired you to never stop exploring, never stop questioning, and never stop playing.